Okay, now I'm working some means out when I haven't got the original raw data, but I've got enough information in terms of summarised data. So I've got 7 coal-fired power stations, and I've got a total of 13 billion cubic metres of CO2. And I want the mean level of CO2 per power station. Okay, so for the 7 power stations, the total of all their emissions is 13. So that means I've got 7 items of data, 7 x values, and the total sum of the x values is 13 billion. So I write sigma x is 13 billion to mean that my 7 numbers in my list add up to 13 billion. Now I don't know what the original numbers are, but I can still work out the mean because the formula for x bar is the sum of the x values divided by n. So we've just done the sum of the numbers. The 7 numbers added up to 13, and n is how many numbers were in the list. So it's 13 divided by 7, which I do on my calculator. 13 divided by 7, my calculator tells me, is 1.857, which I can record as 1.86 to 3 significant figures. Okay. Remember, we always give 3 significant figures. Okay, and the one below is very similar. This time, it tells me a sigma x. What does that mean? Well, there are 30 students. Each has x friends and on Facebook, and when they add all their numbers of friends together, the sum of those 30 numbers is 5543. And I want to work out the mean number of friends, so it's an x bar for a mean. And the total of all the 30 numbers is the sigma x, which is 5543. And there are 30 numbers in the list. So I'm using sigma x over n. So my sigma x is 5543. My n is how many numbers in the list. That's 30. So I do 5543 divided by 30. And I get 184.76. So that's 184.76 is 184.8, or to 3 significant figures, that would be 185. But I haven't rounded to a whole number because I have to. You can leave a decimal in the answer. It's just that 3 significant figures here does actually only take us to the nearest whole number. So 185 is perfectly okay as the answer. Okay, I hope that helps on using the mean from summarised data.